Hey everyone, my name is Natalia Woodbine and I'm a technical architect and capture client success lead at TSG, an Alfresco company. This video will cover how existing Alfresco customers can optimize their intelligent data capture with machine learning by integrating with open content capture. First, a little about me. I've been working with TSG, now an Alfresco company, for 6 years. During my time at TSG, I've worked with a variety of industries, including insurance, life sciences, nuclear, manufacturing, and education. Recently, I've been focused on connecting clients to our open capture solutions. To do this, I've been working with Aubrey Zielinski, a technical architect at TSG. Aubrey has over 3 years of experience in the capture sphere, configuring large-scale implementations for our clients. To start off, I want to cover some background on the evolving goals of capture. Document capture originated in the mailroom, where companies would receive huge volumes of content that would then have to be scanned into their ECM systems. Goals surrounding this were things like identifying page separators, OCR, and handwriting analysis. Following this, the priority was bulk ingestion and indexing. Indexing being the extraction of meaningful metadata from OCR to digitally born content. The push here was really to make this process increasingly intelligent and increasingly automatic to maximize value from the explosion of digital content. This brings us to the goals of today, intelligent capture and beyond. We're looking to leverage artificial intelligence and machine learning, unlimited computing power, and cloud capabilities in order to optimize productivity, affordability, and accessibility. Taking a closer look at legacy capture tools, there are two main strategies for creating indexing templates, zonal and key value pair. With the zonal template approach, a user will indicate the area of a document where a piece of data will likely reside. This is great for known and consistent positional data. For example, you'll always find the invoice number in the top right corner of a document or an address in the top left corner. On the other hand, the key value pair approach indicates a text string key that important data will likely be found next to. This strategy is good for consistent and predictable text labels that could be found anywhere on a document. For example, you don't know what page invoice number would be found on, but you do know that it will be found next to the string invoice number. Each of these strategies is generally augmented with rules for validation and matching. For example, we could apply a regex indicating that invoice number should be only numerical and 10 characters long. This screen shows an example of a zonal configuration indicating that invoice number can be found in the top left corner of the invoice. And this screenshot shows an example of the key value template configuration strategy, in which the value, invoice number, can be found anywhere on the document but always to the right of the key string invoice. Based on our experience with clients using the legacy approach, its strengths are precision, configurability, and handling variance. Basically, between zonal and key value configurations, a client can create a template to correctly index any particular document format. The struggles that we've seen with this approach are lack of scalability and high admin support demands, stemming from the fact that this system does not learn from user feedback. Basically, any variations in incoming content require new templates or changes to existing templates, followed by a path to production deployment of the template updates. This brings me to TSG's Capture 2.0 strategy. Our goal was to build on the base of OCR plus key value pair and zonal templates and incorporate machine learning algorithms to grow and improve the template library based on user feedback in a live system as opposed to admin intervention. So with that strategy in mind, our solution, Open Content Capture, takes the best parts of the legacy approaches and adds in machine learning. This allows it to learn from use in a live production system and solves the issues of scalability and huge amounts of admin support overhead. Additionally, since Open Content Capture is integrated with OCMS, users have access to the whole sphere of OCMS features, including search, enterprise content viewer, forms, workflow, and reporting. To use Open Content Capture, the first step is to create a base template for a type of content that's going to be coming into the system. For the rest of this video, we'll use invoices as an example. So this would mean a user basically taking an existing invoice, uploading it to the OCMS template admin, and then setting up the zonal and key value configurations. The second step is bulk ingesting content into Alfresco using TSG's migration tool, OpenMigrate. Open Migrate can be configured to run against a variety of different sources, such as a monitored email inbox. Upon upload Suggester, the machine learning engine will attempt to index metadata based on the base template created in Step 1. In Step 4, the user will validate or correct the index metadata in the OCMS index module. If Suggester was accurately able to extract the metadata based on the base template, the user simply needs to click OK to finalize the document. However, if the invoice was of a different format or maybe from a new vendor, the user's corrections will be used to train Suggester by extending the machine learning database. So that architecture with a Capture 2.0 machine learning strategy gets broken down into cycles of 2 phases. A shorter learning phase where the system encounters new data and learns how to index that data based on production user feedback, followed by a longer performance phase where the system has been trained and it's humming along mostly autonomously. Consider an example in which a new vendor, TSG, sends an invoice which is added to the indexing queue. Capture attempts to index the invoice using Suggester and the base template for, let's say, Acme invoices. Let's say that the machine learning algorithm only gets 10% correctly since it's really running off of a totally different template, and the user indexes the remaining 90% of the data. Based on the user's input, Suggester learns and generates a new fingerprint key and template for this vendor's invoice. The next time that TSG sends an invoice, Capture 2.0 recognizes the vendor fingerprint. The Suggester engine uses the combined template data of the base template and the new TSG template to attempt to index the invoice. The algorithm gets 100% correct, and the user only needs to confirm. Without any admin intervention, Suggester continues to accurately index both TSG and Acme invoices with minimal or no user input. When a new or altered invoice gets queued up in a legacy capture system, users will have to correct the index attempts until an administrator comes in and reworks the templates. But with Capture 2.0, we make the most of the user feedback and validation phase in order to rapidly scale the template library. Next, I'm going to step through a simple demo showing Suggester improving based on user feedback. I'm going to start off by accessing the OCMS dashboard and taking a look at my invoice index queue. As you can see, I have 3 invoices queued up for indexing, 1 from Acme and 2 from Diversified Benefit. For the purpose of this demo, we'll assume that we've received a lot of invoices from Acme and Suggester is pretty well trained on that template. Whereas this is the first time that we're receiving invoices from a new vendor, Diversified Benefits. To start off, I'll click on the Acme invoice. This brings us to the indexing view where I'm going to select the vendor name. And as you can see, Suggester's done a really good job of populating invoice number, PO number, amount, invoice date, and due date, all from the content of the Acme invoice. So after validating, I'll click Save and Next. So this is one of the Diversified Benefit invoices. I'll select them as the vendor, and as you can see, Suggester was not able to pull off any of the metadata. So I'm going to go ahead and do it manually. Invoice number, double click on the content. Amount, double click on the balance due. And invoice date, double click. So that brings us to our second Diversified Benefit Services document. I'll select the vendor name. And as you can see, it's already done a much better job of pulling off the 3 items that I indexed on the last panel. As we continue to grow and improve our open content capture solution, we have some exciting features up ahead on the horizon. Our roadmap includes extending our data verification framework via fuzzy database lookups, enhanced document splitting based on blank pages and barcodes, integrating with various OCR engines, and enhancing our document classification. That's all for this short video. Thank you so much for watching, and be sure to follow our blog for upcoming videos on open content capture and other solutions.